Hi everyone. This is an exciting video and an exciting lesson because we are going to look at what's called a flowchart proof. Now we have been writing up proofs before, some deductive arguments. Remember, what we're doing in our deductive arguments is we are using a series of agreed upon assumptions and proven facts and taking those general principles and applying them to a specific case to show that one statement flows logically from another and we have the end result and conclusion that we desire. And we did that with the triangle sum theorem. We did that using like the vertical angle conjecture. Actually, I would think it was maybe linear pair, but we did that earlier. And so now we're really going to put all these things together with our triangle congruent shortcuts and then even build upon that after CPCTC. Let's take a look at our warm-up. We know in this figure below that segment EC is congruent to segment AC, EC and AC, and that segment ER is congruent to segment AR. And then the question is angle E congruent to angle A? And if so, let's write a paragraph proof. In lesson 4.6, when we introduced CPCTC, we kind of started writing some deductive argument, some proof, but we didn't really formalize it. So now I'm going to make it really formal. Here's what we would say. So we would say, given, we don't necessarily have to say the diagram that we're given. I would just say our given statements are these two. So we would say given EC is congruent to AC and ER is congruent to AR. We 99% of the time, we're going to start off with our given statements. Then we're going to see if we need anything else to prove what's going to happen. Again, to show that EA is congruent to angle E, is congruent to angle A, my want to show, right, is I want to show that two triangles are congruent. So I want to show congruent triangles. And then after I show congruent triangles, I want to use my CPCTC that we learned in lesson 4.6. In this case, the two triangles are right here. Triangle CER and triangle CAR. So can you see our next step? How are we going to prove those triangles are congruent? We're going to use side, side, side. And then how are we going to get the third side? Because remember, we have one side here and one side here. How are we going to get the third side? We're going to do that by using the same segment, which is segment CR. Okay, and so we can say something like this. Because segment CR is a shared segment, we could say it like that. CR is congruent to itself. And I'm going to flip it around. And then I can say by side, 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 triangle CER is congruent to triangle CAR. And then finally, by CPCTC, angle E is congruent to angle A. And again, we want to end that with our little corner box, our little box, not corner box. This is an example of a paragraph proof. And if you like paragraph proof, that's awesome. You can continue to using that. There's also such a thing as a flowchart proof, which is what this lesson is about. And there's also something called two-column proof. I'm going to take you through a couple examples of what a flowchart proof looks like. And these are scaffolded proofs, meaning you're going to see some of the information given to you and some of the information you need to fill in. So you don't have to do everything on your own yet. When we meet in person, we are definitely going to practice proof together, writing them down on pieces of paper and kind of getting comfortable with the method that we like. And I can also show you what a two-column proof looks like. So for this first one, all we're doing is taking the information that I had above and making it into a flowchart proof. Okay. So note that we have AR is congruent to ER, segment AR is congruent to ER, which we knew is a given. So you make a box, you put step 1 in there, you put the statement in the box, and then the reason for the statement, why can we say what we said, you write underneath the box. So that we write given. If you notice right underneath it, because usually we either stack these statements on top of each other, like moving down, or sometimes we go left to right. It sort of depends on, again, what statements are flowing from other statements, and then just kind of how much room you have on the page. Our next box, notice the reason is given. What is our other given statement that we didn't talk about? Well, we didn't talk about that EC is congruent to AC. That was our other given piece. Segment EC is congruent to segment AC. And then our final given statement is segment RC is congruent to itself. And again, you can just say same segment. You can say shared side. You can say reflexive property. What I want you to notice is these three statements are not connected by arrows. They're independent statements. But then an arrow comes from each of them to the fourth box. And that's because to show that side, side, side is our congruent shortcut, we need to have all three sides congruent. And that has to be established before we use side, side, side. So then once we have those three pieces, we draw arrows from each of them to the step 4. And then our statement is that triangle CER is congruent to triangle CAR. And then because our CPCTC statement always flows out of a triangle congruent statement, then we draw an arrow from box 4 to 5. And the reason why angle E is congruent to angle A is CPCTC. Again, to summarize, start with the given. Statements must flow logically from the ones above or before if you're moving from left to right, and then write down what you want to show as the final step of your proof. Sometimes I work backwards. Sometimes I actually start with the final step I want to show, and then I back it up a step, even if it's not fully fleshed out yet. I know the step I want to right before that, and then sometimes I have to meet in the middle. All right, let's try another one. If you want to pause the video and try this on your own, please do. If not, that's okay. Just follow along with me. In this proof, we want to show that triangle MOS, this triangle right here, is isosceles. So this is kind of an interesting proof. It has a little bit more steps, and that's exciting because now that we have our skills and we have more conjectures that we know, we can then, of course, prove more difficult, complex ideas. And to prove something is isosceles, let's just go back to here, right? What does it mean to be isosceles? You have to have two congruent sides. So at least two congruent sides. So we have to show that some sides are congruent. Well, in triangle MOS, okay, if we're just looking at what we have already, we have SE is congruent to SU, and angle E is congruent to angle U. So it looks like I have some triangles here and here, okay? And then that means I'm going to have MS and SO, or OS, as our congruent sides in triangle MOS. That's our isosceles triangle. So here we go. SE is congruent to SU, and that is given. Angle E is congruent to angle U. That is given. Let's look at step 3. Angle 1 is congruent to angle 2. 99% of the time, if they give you a labeled angle in the diagram, you're going to want to use it. And so why? Why is angle 1 congruent to angle 2? Vertical angle conjecture. If you cannot remember, vertical angle conjecture, you can just say vertical angles are congruent. I'm fine with that as well. I don't want you to just say vertical angles, because there's technically a difference between what the definition of a vertical angle is and then the fact that vertical angles are congruent. And that's something that we just have to kind of parse through a little bit. I gave you the triangle congruent shortcut. It's angle, side, angle, which hopefully as you read the diagram, you're able to figure that out. It's okay, again, when you write your congruent statement, you might write something a little different than mine. As long as every corresponding piece is in the correct order, you're fine. So I'm going to call this triangle, and I'm not going to squeeze it in this box. I just don't have enough space. I'm going to call it triangle MES, and then triangle MES is congruent to M to E to S. is triangle OUF. Again, that was by angle, side, angle. And then finally, MS is congruent to by SO by, yes, that's right, CPCTC, our favorite. And then now that we know that this segment is congruent to this, we can definitively say triangle MOS is isosceles. And this is where we write definition of isosceles. One quick note, this is not the isosceles triangle conjecture. That tells us the base angles are congruent. That's not what we're trying to prove here. We're just trying to show that the triangle is isosceles. So this is by definition of isosceles. Okay, one more to go. Again, feel free to pause the video. As you notice, this one has even more blanks. So and more steps. I'm trying to build up our muscles here when we work with proof. It takes time and practice, so just keep working through it, and I am here to help you. This is what I call the classic bow tie, because it sort of looks like a bow tie to me. And there's a lot of different ways the bow tie can present itself. Sometimes we have congruent angles, sometimes we have parallel lines, sometimes we have segments that are congruent. In this one, we know that I is the midpoint of segment CM and segment BL. So here's our midpoint. Now, that implies, what does I is the midpoint of these things imply? Well, it implies that we have then the segment is bisected and we have congruent subparts of that segment. So what you will notice here is our first step is I is the midpoint of CM. So here's segment CM, and that is given. It's given that I is the midpoint. Now, what is a result of that? And that's where our arrow comes in. The result is that segment CI is congruent to segment IM. And that is by definition of midpoint. We're going to repeat that step, and by noting that I is the midpoint of BL, the other segment. Again, we're going to write given here. Because that was given to us, we also know segment IL is congruent to segment IB. And that's when we write definition, and I use DEFN as my abbreviation of definition of midpoint. Why is angle 1 congruent to angle 2? Again, vertical angle conjecture. We've been using that one a lot. Ooh, this one's completely blank. I didn't give you the triangles that are congruent, nor did I give you the reason why they're congruent. So this is a good exercise for us, a good thing for us to think about. Our triangles are triangle CLI and triangle BMI, but we have to make sure we have the right order. So if I go from C to L to I, okay, CLI, then I actually have to go MBI. Why are our triangles congruent? Well, they are congruent by SAS, side, angle, side, because I have a side, an angle, and a side. And then our last step, segment CL is congruent to segment EM or MB. I want to make sure I get that right. By CPCTC. And there we go. So in the online homework, you are going to have a couple of these kind of scaffolded proofs here. They might not look like flowchart proofs. They might look more like 2-column proofs, but I think you can put it together, and it's going to be a bit of a drag and drop, and they should be scaffolded for you. You're not going to have to just completely come up with a proof out of thin air. We will continue to work on that when we meet. Great job.